day of eating and nothing. That's what they do in my kids' school. They give them like freaking 2 weeks off and like for 1 day. They get 2 weeks for Thanksgiving and then they get 2 weeks for Christmas. I'm like, are you guys paying these child like babysitting bills? I'm like, damn.
All right, guys. So everybody.
Elementary.
Everybody means like every single person is what that means. After the break, I'm going to give you an updated homework sheet that's going to have what we're going to do for the rest of the semester, and there's not much of the semester left if you've been paying attention. So we will be doing more stuff after Chapter 8. Chapter 8 is like a review chapter, but it's really making sure you understand how important solving equations is. You want to go into Math 90 knowing how to solve equations, no problem, right? That shouldn't be the problem. Any questions from stuff we've just gone over? Anything from we just got into conversions. Guys, hey, what's going on? We just got into conversions. Anything from there, before that? Any questions from homework? Yes.
Wait, homework lately or any?
Hit me with what you got.
6.3, 167.
All right. What's the problem say? Okay. I've given all my chapter 6 stuff away. Well, I mean, I wasn't expecting that.
Okay, never mind. Let's see something else.
And that's from the last test.
Someone asked the question.
What are you Jack? It's because I was stuck on it.
And I couldn't figure it out.
How do you know? Right?
It's not my fault he said, come on.
I decided.
It's not my fault he was
It's not sure.
You say 6.3, Jackie?
6.3, yeah.
All right. I got somebody's here. Which one?
167.
167, okay. And that's the one that says Hamal works at a car dealership? You don't know. Okay. Receives a 9% commission. Does that sound familiar? Okay. Alright, so I don't need this guy. This is 6.3, number 167. Hamal works at a car dealership, receives 9% commission. For Jamal. How much commission will he receive for selling a $32,575 car? Yeah, so guys, you're making such a huge deal out of some of these percentage problems. If it's sales tax and they say it's a 5% sales tax and you buy something that costs $120, how do you figure out how much tax you're going to pay? 5% of 120. Right, so percentage of the base amount. So if he makes 9% commission on whatever he sells, and he sells a $32,575 car, how do you figure out how much commission he's going to get? Well, you take 9% of. What do you take 9% of to figure out how much commission he's going to make? Not of 100. He didn't sell a $100 car.
Of whatever the car costs.
Yeah. So he's not always going to get $9. This poor dude. You'll get 9% commission. They always just give him $9 no matter how much the car costs. Obviously, if the car costs more, he's going to get a bigger commission. So why does that make sense? Because I take 9% of whatever the cost of the car is. So this is exactly how you figure out if there's a 10% discount. How do you figure out how much money they're going to take off? You take 10% of the cost, right?
So multiplying?
Yes. Of means multiply. I like it. So this would be just 9% of 32,575. And the 9% of course is what?
0.0.
Yeah, 0.09. Don't multiply by 9 and get this guy all excited, he can retire.
90, yeah.
And whatever that is.
Yes.
Is that cool? I mean, a lot of those problems are the same exact kind of problem. How do I figure, if I would have said, there's a 9% sales tax, and you want to buy this car, how much tax will you have to pay? You do the exact same damn thing. Because it's 9% of the thing, whatever that is. If I said it was a 9% markup, 9%, the 9% discount, this would be the first step. First step.
So
Yes.
basically, we need to know what the ofs and the words are
Yeah, we know.
Yeah.
Of is the most important word when you're talking about.
to be subtracted. I mean, addition. I mean, multiplication.
Man, we're gonna go through
You know
all
what
of
I
them.
mean?
It means. It means the only operation I'm not gonna say, Joe. All right, that works. All right. All right. So, anybody else have questions from homework stuff? Homework stuff? No. Okay. I don't know, guys. I normally say I'm an optimistic fool, but I have a bad feeling that means that we are not doing all of the homework. I don't know. Which is a bad way to be. Alright. Okay. So last time we got into converting between different types of units. Guys, we converted between like feet and inches. We converted years to seconds. I think we went that far. I can't remember. Just to remind you guys, and then I got a nice little handout that kind of displays out the process. Okay. So it doesn't, I really want this to make sense. The beautiful thing about this process is it doesn't care what the units are that you're using. The process works no matter what. So let me give you a couple of standard ones, and then I'll give you like an outlandish one, just to show you that the process doesn't care. What do you mean? Okay, outlandish means great. So let's say I want to know, let's see if you guys remember this. 0.9 miles is how many feet? Now don't freak out. I'm going to give you conversions. I'm not going to make you memorize them. I'm not going to give you 12 inches in a foot. You got to freaking know that. But I will give you this one because not all of us know this one. But maybe somebody remembers. How many feet in a mile?
2,620. Oh, it's way out.
Yeah, you suck. You're fired.
Yeah, I'm going to stop paying you. Oh, yeah. Okay.
About half.
How do you get so many people to show up? I pay them. No, I don't. Don't get excited. I'm a teacher. I don't have enough money. All right, guys. So all right, stay with me now. Stay with me. It's almost too good to believe. You've got to be with me on this. It's almost too nice to believe. And let me say it to you like this. There's other ways to do this besides the way that I showed you. Just look at this. 1 mile is 5,280 feet. So 2 miles would be, what would you do to figure out what 2 miles is?
Just double it.
You would just double this. So half a mile, you would just
Half that.
cut it in half. So 0.9 miles, I'm going to multiply this by 9/10, and that's what I'm going to end up doing, by 0.9. Now, do you have to remember how to do all that? No, but my point with that is, it's always you're either multiplying by the number or dividing by the number. Yes,
So
ma'am.
if it's like any time in like decimal, you play math.
Say again, say again. So what I'm saying is, if I have a mile, in that mile there are 5,280 feet. So if I have 2 miles, then I have 2 sets of 5,280 feet. So whatever the number of miles is, I'm going to multiply 5280 by that to get how many feet I'm talking about. You guys got it with me? Let me take a smaller unit so we can see. 1 foot has 12 inches in it, right?
Yeah.
So then if I wanted 3 feet, I would just multiply 12 by 3. Now what if I said I had 48 inches? How many feet would that be?
4.
Then I would divide 48 by 12 because it takes 12 inches to make a foot. So if I got 48 inches, my question is, how many groups of 12 inches do I have? Because each one of those is 1 foot. So 48 divided by 12 is 4. So it would be 4 feet and 48 inches. So the whole thing about converting is, do I multiply or do I divide by this conversion number? And that's what this process that I showed you last time kind of does for you. It just puts the number in the right place so that you divide or multiply at the right times.
Okay, how are you gonna know which when and which to do?
That's what I'm saying. This process makes it so you don't have to sit there and figure that out.
He's going to show me.
It explains why the process either multiplies or divides, because that's all that ever happens, right? You either multiply or you divide. The whole question, like you have, Jesse, is when do I do which one? And that's the beauty of this little thing that we set up. So if I have 0.9 miles, the only thing that you really have to remember is, where do I put the miles? Yeah, which one? Bottom. Why on the bottom? Because I want to get rid of the freaking mile. I don't want miles, I want feet. I want miles out of there, right? So I put miles down here so that they will end up canceling. And now look, you just sit back. Now see, that process right there was barely mathematical, really. It was miles canceling when there's no numbers yet. Now you put the numbers where they're supposed to go.
On top.
Yeah, which numbers go on top?
Feet.
Yeah, so 1 mile is 5280 feet. Now some of you guys could probably figure out when to divide, when to multiply. So you're not going to have to do this necessarily, but if it's a long chain of it, you might want to set this up for yourself. You guys kind of with me here a little bit? So if I would have started in feet, I would have put feet down there. The 5280 would have been down here. I would have divided by that. Because it takes 5,280 freaking feet to make 1 mile. So whatever number of feet, I'm going to divide by that to see how many miles I can make. Right? Do you actually have to understand what I just said to do this process? No. But I really want you to understand why this works, why this process works. It's so nice. All right. And then whatever that is, somebody help me out. What's that? 4680. 72, 47, 52. Can somebody help me?
Calculator?
Save me from my own brain.
Calculator?
4,750.
Oh, okay. Yay, Jeff! Doing your job. All right. Okay. So, I want to go a little beyond this, and then I've got a handout that's got this process on it with some problems I'm going to want you guys to do on your own. I want to go a little beyond this so I can include that in this idea, which you already have, actually.
Real quick,
Yes, Jesus.
before you leave that. So, like, the 5,280 makes a mile. So even if it's a little more than a mile, you just do the same process.
All right, let's do that. All right, let's do another one. Let's do a few more of these, actually. It's probably a good idea. Let's say I've got 1.2 miles. Is how many feet, right? So the process says, take where you are now, set the units up so that'll get you to the units you want to be, and then you throw the numbers in the right place. It's almost too nice to believe. If you haven't taken chemistry yet, this is a huge part of
The other
chemistry.
way around.
Say again?
Like,
Oh yeah, we're going to do the other way around. We're going to do feet, miles. But Jesse asked you a question. What if that number was different? It actually doesn't matter what that number is. Do you see what I'm saying?
Yeah.
Because you're gonna, if it's whatever miles, I'm going to put them up here. That's where I am now. So where's miles going to go over here? Bottom again. I like that. Jesse has a question. He already sounds bored. On the bottom again. And now where does, and again, the same thing.
you're still going to use 5280, correct?
Definitely. This is true if I'm talking about feet to miles or miles to feet.
Yeah,
Those are the numbers I gotta
over
use.
miles, so we would have to figure out what the .2 is, correct?
No. No.
No,
No.
that's what's
No.
gonna be off.
What do you put down here? What's the conversion?
1 mile.
1 mile.
1.2 miles.
No. 1 mile is
1 mile is
5,280 feet, right?
right.
I made my 5 look like a 2. What do we do here? Did we do anything? No. All it cares about is the units. That's all it cares about.
Okay, where's the .2 going then?
No.
You multiply.
You multiply 1.2 times this. Now watch. Now stay with me. Stay with me. I'm going to go a little further than I normally would, but I love the question you're asking, Jesse. If it was 1 mile, that would be silly. I wouldn't even set this shit up, right?
Right.
1 mile is freaking 5280 feet. That's the conversion itself. So you're worried about that you have to take care of the .2. No, this is supposed to change it into feet. So 1.2 times 5,280. Now, guys, stay with me. Well, some of you guys get with me in the first place. All right, whatever. Fail the next one. So here, now watch. This is kind of cool. Isn't this 1 plus .2? Isn't that weird? Isn't 1.2 1 plus .2? Is that extra you're talking about, right? Don't freak out on me now. What's 1 plus .2? 1.2. Is that cool? All right, let me make sure. You guys, I'm trying to show you a different way to look at this. Am I saying that you have to do it this way? No. Now stay the hell with me. What do you have to actually do to do this problem? Multiply 1.2 times 5280, you're done.
Right.
I love it.
Right.
But Jesse, I like your question. Stay with me now.
Okay.
Now watch. Stay with me now. Is it cool so far?
Yes.
If it was 1, I would just get 1 times this, it would be done. 5280.
Right.
I want to show you that the process actually takes care of the extra .2. So 1 times this is 5280. Plus 0.2 times this. That's in there. It includes the extra. When you multiply 1.2 times this, the extra gets added in. Right there, that's the extra getting added in. Do you have to do this, dear God? No. Why would you do this shit? And don't look at me and say, why'd you do that? Because I'm trying to explain to you another way to see why this doesn't... You don't have to think about it. That's the beauty of multiplication.
We're just going to simplify it like that. But
Yeah.
in case we want to get dumb and difficult, then we'll...
6,336.
Say again? So what do you get when you multiply?
6,336.
All right. You think? Well, okay. Your calculator, if the batteries are good, should be telling you the right answer. All right. Maybe.
But what if, I want to know how to do backwards.
Say again?
Feet into...
Don't do this. Okay, cool. We'll do it the other way. You cool, Jesse?
Yeah.
I like that because
I'm doing mine the easy way, so I'm cool.
Oh,
I just wanted
no.
Just
This isn't even a way. You understand? I wouldn't even call it the hard way. I'll call this the crazy ass way.
Crazy ass.
But this mathematics is true, and you can see the extra .2 that gets added in.
Right, because all you doing is...
But don't do it that way. It's insane. It's an insane way.
Yeah.
All right. So if I went the other way, let's say I have 498 feet. I want to know how many miles that is. Now let me just ask you right off the bat: is that a full mile?
No.
Is that half a mile?
No.
Hell, that's some small part of a mile, right?
Mid-June.
Oh, I get it, dude. But I don't have to know the answer, thank God, right? I just do the process. Guys. So, you set it up. And it doesn't matter which way you go. I don't have to somehow know this any other way than where am I going to put feet? On the bottom. And from feet, I want to go where? To miles. And do I have a connection between miles and feet? Yes. No. No. So where do I put the numbers now? How many miles and how many feet? 1 mile is 5,280 feet. So let me ask you a weird ass question. What is 1 mile divided by 5,280 feet? 1. 1. What's a foot divided by a foot? 1. So what's 12 inches divided by 1 foot? 1, because they're the same damn thing. Isn't something divided by itself 1?
Yes.
So I'm multiplying this number by these, and somehow I'm saying you're not. That's the same. And of course it's the same thing, because this is 1. So how do I do this in the calculator? I take 498 divided by 5,280.
Right. Because we divide the feet.
So there is something interesting. Whenever you're going from the smaller unit to the bigger unit, you see how feet are the smaller unit, miles are the bigger unit, you're going to divide.
Right.
Whenever you're going from the bigger unit to the smaller unit, you're going to multiply. Now, I'm not saying you have to memorize that, but if you like that idea, keep it. I love it, because it's true.
Smaller to bigger, we're dividing, right?
Smaller to bigger, you divide. Bigger to smaller, you multiply. So what is 498 divided by 5280?
0.09.
109,
Blah, blah, blah.
other stuff?
Miles.
So approximately.
43181.
Alright. I like it, I like it.
So just do.
What's 498 divided by 5280? You told me what to do, right? Just plug it in the calculator.
Oh, okay.
Yeah. Don't give me credit. I didn't do that in my head. I waited for somebody to tell me.
So we have to divide, right?
Say again?
So we have to divide, not multiply, right?
Yes, that's what I said. Yes. Cool. I like it. Hey guys, everybody having little side conversations. You can head out the door if you need to talk. You with me? I like it. It's okay. Just don't do it again. All right. All right, now you're gonna have a discussion about what I love it. He said not to talk. No, I know. I heard. All right, shit, just stop. All right. So on one side of this, actually, let me go a little bit past this. I'm gonna hand this out in a minute. I got one little thing to talk about before it, but I got the process, some examples of this process, and then some problems for you to do. But we're actually gonna get into the metric system a little bit. I just looked it up. I didn't even know this. There were 3 countries that don't use the metric system on the face of the earth. And we are still one of them. But the other 2, Myanmar and Liberia, they are actually changing to the metric system over the next several years. So it's just going to be us on the face of the earth. Right? Kind of goes along with us being different in a lot of other ways. So, yeah, America.
Do you think that's ever going to change?
What's up?
Do you think that's ever going to change?
I don't see it.
Well, we do use the metric system, just the only time I can ever think about it, like, normally is, I'm an ex-engineer, so tools.
Oh yeah, so we talked about that a little bit. We
Yeah.
have tools that are both in like 1/16 of an inch,
Yeah,
and there's also tools in millimeters.
Yeah.
You go to the store and you buy a what of soda? A liter or 2 liter of soda, right? There's one sign I've seen on the 15, I think, or the 5 going north that you see the distance in kilometers. One sign in all of California.
Where?
Going north on one of those, I don't remember which one it is.
It's got to be a foreign person.
I want to see.
Try pulling an international into a Volvo shop and change the tire.
There you go.
Then you're going to be.
There you go. So you got something that was constructed in another country. It's probably going to involve parts that require metric measurements. And if you only got non-metric, they're not going to go together. I like it. So there's many of us, when you're trying to take off a nut, you're like, I only got the 16th of an hour. How many millimeters? Ah! And then you get pliers and you just
That's why you gotta carry around your 9/16s. That's the magic tool.
All right.
9/16 box.
So, metric. What do you guys know about the metric system already? Yes, you do. You know something. Tell me some units in the metric system you know. You know something.
Kilometers.
We just said one. Liters, kilometers. I like it. So there's kilometers.
Millimeters.
Bless you. Centimeters. That's way down here. So there's a couple of units that people normally don't know. And kilo. If you watch enough cop shows or something, you know what kilo is. It's how much? Kilogram. Kilo means what, though? How many grams? 1,000 grams. So kilo is 1,000.
What helps me remember is like 10K, right? Is that correct? Like 10K.
10K.
Kilo.
Oh yeah,
Kilo,
10,000.
10K.
Yeah, very often you see the K for 1,000.
Yeah.
Exactly.
10K.
I like it.
K.
There's two here that people normally don't know, and I don't blame you. They're not used very much. And then there's straight up meters. And then there's one here that we don't normally know. And then there's the two small ones that we normally know, the centimeters. And what's smaller than that?
Millimeters.
Millimeters.
Yeah.
No.
Are
Yes.
we gonna have to remember this for the test?
I'm going to show you a very nice way to remember this in just a minute. It involves drinking chocolate milk somehow.
Yes.
I'm lactose intolerant.
Really?
You don't have to say it. You don't actually have to do it. I couldn't pass this guy's test.
I just
Want us to drink milk?
I like heckling you sometimes.
All right. You like playing out the thing. All right. Now watch. This is kind of cool. So kilo is 1,000, and notice how. So here's one, like one thing, one in the middle. It takes 10 of these to make this, and this guy is decameter. Either spell with a K or a C. I've seen it both ways, but I'm so used to the K that I'm going to do it that way. Decameter.
Deca is 10.
Exactly. And deci means tenth. So if I go the other way, I always think of this as the whole number of meters, and then this is like the decimal. So this is decimeter. Deci. I like it.
Different, yes.
And then in between these guys is the weirdest one. Hectometer. Oh, cool. Alright, so a kilometer. You guys have a really rough idea of a kilometer. A hectometer is 1/10 as long as that. Every step I take either goes down by 1/10 or it gets multiplied by 10. So it takes 100 of these. And why does that make sense? This is centimeter, centa. Hundreds, right? Percent, like percent. So it takes 100 of these to make one of these.
So make a meter.
Yes. So how many of these does it take to make a meter?
1,000.
1,000. I love it. Kick ass. Shut up. Be quiet. All right. Now watch. This is kind of cool. You might be a little worried that you have to remember all these little intermediate steps. But what's so freaking beautiful is if I knew, for example, I have 0.006 centimeters, and I want to know how many decameters that is. How many steps do I have to take to get from centimeters to decameters? 1, 2, 3. So then I just take a decimal point and I move it 3 places in the same damn direction. So metric system is based on 10 because our number system is based on 10, and I don't know why that is. Why we have a number system based on freaking 10, right? Because we have 10. So if we had 8 fingers, we would somehow have a number system based on 8. But let's not talk too much about that. You can take my 120 class and we'll talk about that. So what would this become? This would become 1, 2, 3 back. So 1, 2, 3 back. So it would become 0.000006 decameters. Let's do another one. That one's kind of freaky.
What are hectometers in?
100.
Oh, the 100 going the other way?
Yeah, this means 100 meters. This means 1,000 meters. This means 10 meters.
And then
I like it.
meter is 1.
But it's just going
So
up.
how would you write the? Sorry, I'm trying to like make a chart. How would you write decimeter, like visually, like writing it down?
So how would you write what I just did?
Yeah. Like
So it was
tens.
0.006 centimeters, and then it just becomes 0.00006 decameters. I don't know, you just move the decimal back. That's all you got to do. There's no writing down anything except the little motions going back.
Never mind.
It's beautiful. We know this by now. When I multiply by 10, what happens to the decimal?
Right.
It goes up once, right? If I divide by 10, it goes back once. So every step back, I'm dividing by 10. Every step back, I divide by 10. I love it. Because percentages are out of 100 because our number system is based on 10. So we picked a number that's a multiple of 10 to make percentages based off of. I like it, I like it. So what about this one? What if I had, what you got, Jeff? 0.057 hectometers is how many decimeters? Yeah, so I'm in hectometers. How many times do I have to move to get to decimeters? 1, 2, 3. Cool. So then you move the decimal that many times in that frickin' direction. I mean, good Lord. How easy is it to convert in our units? Can you go from tablespoons to gallons for me quickly? Hell no. Hell
Never.
no. Right? Our system is insane. This is all by tens. So the only thing is, you guys are like, I don't know how big a decimeter is because you weren't brought up in it. You all know about how big an inch is. Why? Because you were all brought up in that system. So if only we had the metric system, everybody would know how big that was because that's what they would be brought up in. So how do you do this one? So how many times again? I got to go 1, 2, 3. So 1, 2, 3, 57. Done. I like it. And real quick, couple things. I always remember this one's bigger because damn, it's big. I like it. Right? It's unfortunate we got deca and deci, so they're so much like each other. But when I say DAM, damn, so that's the bigger one. Secondly, if you know how to write this down, you can do any metric problem real easy. Are you guys semi with me on that? All you got to do is